go through each function you might use to implement this project. And this project actually is a little bit challenging, and I hopefully this video can help you to understand how to finish this. Okay, so this project can be divided into two parts. One is that you need to do the edge detection of the image, and after that you need to use a half transform to convert the image from the image plane to the parameter plane. Okay, so let's get started with the edge detection. And before you do the edge detection, you need to implement the convolution function, right? So this function is to do the convolution, and the input of this function is the original image and the convolution filter, and the output is the image after the convolution. Before we do the convolution, we need to do the zero padding. So you can use this function, the paddle array. You can check the how to use it on the website, and you can choose which padding you want to use, the replicate or zero padding. Yeah, and so you need to be careful with the size of the padding, because the size of padding depends on the convolutional filter you choose, because convolution filter can be 3x3 or 5x5, right? And after that, we need to do the convolutional filter, convolutional, and operation. We will input. I use four loops. The first four loops is goes to each pixel in the image. You can say from the starting row to the end, the starting column to the end, and this two for loop is used to calculate from the starting row of the filter to the end, and from the starting column filter to the end. Okay, so, and here what we need to do is multiply the each values and add them together. So it's a definition of the convolution. So after that, we need to do the edge detection. So usually before we do the edge detection, we need to blur the image and eliminate the errors, right? So we need to define the Gaussian function first, and define the super function in x and y direction. And after that, you will call the function myImageFilter. Already done that, and calculate the gradient magnitude and the angle. So after that, we needed to do the non-maximum separation. Why? Because the high gradient magnitude region sometimes are too thick. So we just need to use a 1 pixel line. Okay, actually the NMS can be done in multiple ways, but here we already gave you a rules of how to implement this. I will give you an example. For example, this is a part of the image. The center pixel is A22, and if the angle of the A22 is equal to 50, 50 is closer to 45, right? Not rather than the 90. So we will compare this diagonal, these three values, and okay, let me give you another example. The A22, 100 is closer to the 90, not the 135. So we need to compare this, and this. Okay, so after combining these three pixels, if the neighbors is larger than the center pixel, we will set the edge magnitude at the center pixel to there. Okay, so let's do the half transform. So this value is actually defined. You don't have to define this. I just actually it's already defined in the EC function. Here, the rho should be the 2 and the theta pi divided by 180. Okay, so and the rho should be large enough to accommodate all lines that could lie in this image. And the rho maximum, in my code, I define the rho maximum as a square of this, and the maximum theta will be the 2 pi. And actually, you can use these values to calculate the scale of this image and how many pixels, what's the size of the rho and the theta. Yeah, you can, and you need to use the size of this to determine the vote matrix. So the vote matrix, they will store the votes. Okay, and then we need to convert the image from the each pixel to the parameters. So we'll use a for loop again, and in each pixel we will determine the pixel is larger than the threshold or not. Yeah, threshold is one input of this function. And if larger than the threshold, we will find the corresponding rho and theta, and we will add the vote matrix of the I, J will be incremented by 1. So after that, we will get a matrix that store the votes for each I and each J. And then, so we use the half line to find the top 30. Actually, the n line is defined as 30 in the function. If you, yeah, 30. So we needed to find the top 30 voters, right? So here we still needed to use a non-maximum separation first, but this NMS is different than the one we used in the edge filter, because we don't have to consider the angle of the magnitude this time. We just need to compare all the neighbors. And then we need to sort. You can use the sort function because we just want to find the top 30. So we can use the top function, the sort function. You can check how to use sort function in the MATLAB website. And we will create a rho and the theta array. The size will be n lines times 1. So you can, for my code, I use a while loop, and you can use a for loop, whatever you want. And when index less than the n lines, we will find use a find function to find the corresponding index, and we will give the value of the rho of this index. Yeah, and each time the index will be incremented by 1. So after that, we will find the top 30 values with highest votes. So that's how we implement the half lines. So that's every function we did to